All right, so now that we've taken a look at mapped types, let's take a look at another more complex type in TypeScript that builds off of generics that we learned about earlier. Now, what we're going to take a look at here is something called conditional types, and it's probably easiest if I just walk you through an example in order to explain it. But first, though, just to make sure that this file here isn't highlighted in red, let's just eliminate some of the errors that we purposely typed in our mapped types file. I'm just going to comment these out so that we still have them around, and you might even want to add a note to it like this doesn't work, just as a reminder if you want to. Okay, and what we're going to do here is I'm going to create a new file for our examples, and we'll call this something like conditional types.ts. All right, so the idea of conditional types is to allow us to add a little bit more logic into certain types of generic types that we might define. So in order to get an idea of this, let's say that we wanted to create a function that could add either two numbers together or two strings together or a string and a number. So just bear with me here. What we're going to do is we're going to say function, and we'll call this function something like combine. And what we're going to do here is we're going to add two arguments, both of which can either be a string or a number. Okay, so we have A and B, which can also be a string or a number. And the return type of this, as you might imagine, is either going to be a string or a number. However, one thing to notice here is that depending on the exact types of A and B, we know exactly what type it's going to return. All right, so while it might be tempting to just take the easy route and say that the return type for this is either going to be a string or a number, and by the way, it would be either a string or a number because in JavaScript and TypeScript, if you add two numbers together, like 4 plus 4, that's going to return a number, whereas if we say something like 4 plus hello, that's going to return a string, right? That's specifically going to return the string for hello, right? And likewise, if we add a string and a number, right? If we were to say hello plus 10, let's say, that would return the string hello 10. And obviously, if we add two strings together, if we were to say hello and then comma Sean, that's going to return the string hello Sean. All right, so in other words, unlike with some other examples that we've seen before of returning union types where the function could return either one type or another, but we don't really know based on the types of the arguments, with this function, we should be able to know exactly which of these types, a string or a number, it's going to return. And this would make things easier for us because if we now say return A plus B, let's say, and as a matter of fact, TypeScript isn't going to like that. So what we actually have to do in order to make this work, and don't worry too much about the details here, is we have to check to see whether both of those arguments are numbers. And if they are, we'll add them together as numbers. And if one's a number and one's a string, or if they're both strings, we're just going to convert them to strings and then add them together in that way, right? TypeScript just doesn't like that we're trying to add two of these union types together, even though all of those combinations would actually work. So what we're going to do is we're going to say if, and just like in JavaScript, we can use the type of operator in TypeScript. So we're going to say type of A is equal to number, and type of B is equal to number. Well, in that case, what we're going to do is we're just going to say return A plus B. And notice here that TypeScript has automatically been able to infer that since the type of A is a number, right, if we hover over this now, we see that it knows that A is a number type-wise as well. So in other words, TypeScript pays attention to these type of operators and uses those to sort of narrow down which types a given variable or argument could be. So while A out here could either be a string or a number, inside this if statement, it knows that A is a number. So what we're going to do here is we're just going to say else. And then what we'll do is we'll return A plus B. And what we're going to do is we're going to say A as string plus B as string. And what this does is it just tells TypeScript to treat these both as strings. So anyway, getting back to the original point that we were making, we know that if both A and B are numbers, then the result is going to be a number, and any other combination is going to return a string. However, if we were to now use this combine function and say something like let result equals combine, and then pass in something like 10 and hello, Well, TypeScript isn't actually smart enough to go through this logic and tell which one of those results is going to be the case, right? What the actual return type is going to be. And if we hover over result, you'll see that the type of this thing, even though that we know that this is going to be a string, the TypeScript type here is string or number. And what that means is now, even though we know that this result is a string, we can't actually treat it as a string without TypeScript complaining. So if we were to make a function called something like, reverse string that takes a string as an argument here. All right, and I'm not going to actually implement this here, but the point here is that if we were to now try and call reverse string with this result, well, TypeScript isn't going to like that because, again, even though we know that result is a string, TypeScript, because of this return type here, says, well, it could also be a number. Now, here's where conditional types come in. What we can actually do here is say something like type, and then let's call it something like string or number. And then what we're going to do is we're going to actually have this take two generic types, which we'll call T1 and T2. And based off the types of each of these, we're going to give TypeScript here the ability to tell whether the return type of this should be a string or number based on what the types of the arguments are. So here's what that's going to look like. So I'm going to say T1 extends number, and then we can actually use this ternary operator thing to determine what type we want to return for this. So what that's going to look like is we're going to say T1 extends number, and then we're going to check what the type of T2 is, right? If T2 is also a number, and then what we're going to do is we're going to say number, right? Because if both T1 and T2 are numbers, then the return value of this combine function is going to be a number, right? We just know that based off of just basic logic. All right, now on the other hand, if either T1 or T2 is not a number, then we know that the return type is going to be a string. So what we're going to do is we're just going to say colon, string, and then we'll need to add another colon and say string as well. Now, don't let that confuse you too much. Ternary operators tend to be a little bit difficult to read, but all that this is saying is if T1 and T2 are both numbers, the return type's a number. Otherwise, the return type's going to be a string. So another way that we can make sure that T1 and T2 are both either a number or a string, because right now they could be really anything, is by adding the extends keyword inside these triangle brackets. And what that allows us to do is restrict the types that this generic type can be used with, right? So we can say T1 extends, and then we can say string or number. And we can do the same thing for T2. We can say extends string or number. And in this case, we know that T1 and T2 can only be either a string or a number because TypeScript will complain if we try and say something like let x string or number. And then let's say we try and pass an object there, object and object. Well, TypeScript's going to complain about that. It's going to say type object does not satisfy the constraint string or number. Okay. So anyway, now that we have this string or number type, and in fact, if we want to rename this to make it a little bit more clear what's going on here, we could always just rename this type to something like combination result. All right, so basically what this is it's the type that results from combining type 1 and type 2 that we pass as generics here, right? Cool, so now that we have this type, what we're going to do is we're going to rewrite this combine function so that TypeScript will automatically infer what the return type is based on the types of the arguments. So what that's going to look like is, first of all, we'll need to add a generic type to the combine function itself, right? So we'll need to say T1 extends string or number. And actually, it's going to be the exact same thing that we have for our combination result type here. So what we're going to do is we're going to paste that there. That'll make sure that type 1 and type 2 are either strings or numbers. And then for the types of our arguments, we're just going to say T1 and T2. And that means that TypeScript will now basically infer what T1 and T2 are based on the types of arguments we pass, right? So we won't ever actually need to pass in these generic types with triangle braces when using this combine function. All right, and last but not least, now what we can do is as the type, instead of saying string or number, which as we saw gave us some problems when we wanted to actually use the resulting value for some purpose, what we can do now is we can just say combination result, and we're going to specify T1 and T2 like so. And this does mess things up a little bit inside of our function body here. All that we're going to need to do is specifically cast the result so that it's a combination result. All right, so what that means is we just need to put A and B in parentheses here and then say as combination result T1 and T2. And the same thing for this return statement down here. We just need to put this whole thing in parentheses and say as combination result T1, T2. And this might be a little bit advanced type-wise, so don't worry too much if you don't understand why we need to do that. Just know that it has something to do with how TypeScript makes sure that types match up. All right, so anyway, now that we've done that, what we should be able to do is when we call our combine function and assign that to a variable, right, such as result, we see that TypeScript automatically knows that that's a string. And if we were to change our string here to another number, let's say, and then save it, well, immediately we see that this thing underneath it has a red underline now because result is now a number, right? So if we hover over result, sure enough, we see that it says let result number. So this is just one example of how conditional types work in TypeScript. It's a pretty advanced topic, as you can hopefully see by now. So really the main goal here has just been to show you what conditional types look like and a very common situation where you might need to use conditional types in order to just make your type system more robust in the program you're creating. So anyway, that's how conditional types work. The next thing that we're going to take a look at is something called indexed access types.